Welcome to the physics class. Welcome once again. BSc third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, in unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer, in the session 11th, we have to study about problems based on dielectrics. So now we see the some of the formulas, list of formulas. So in this chapter dielectrics, we learnt about certain formulas. They are dielectric constant epsilon Rk is equals to Cd dividing by Ca. Cd means capacitance of the dielectric and Ca means capacitance of the air. Or this formula is also written in terms of C dividing by C naught. In the electric displacement and in a dielectric medium is an electric displacement vector. D is equals to epsilon naught epsilon R into E, and also used another formula, D is equal to epsilon into E. Here epsilon is equal to epsilon naught into epsilon R. Next, the relationship between D, P, E means in polarization, P is equal to D minus epsilon naught into E. And the boundary conditions between E and D, electric vector and displacement vector, that is K1 by K2 is equals to tan theta 1 dividing by tan theta 2. Flux density D is equal to epsilon naught into epsilon R into E, and D is equals to epsilon naught E plus P. Polarization P is in terms of permittivity epsilon naught into epsilon R minus 1 into E, and also used P is equal to N alpha E. In an electronic polarization, alpha E is equal to epsilon naught into epsilon R minus 1 dividing by N. Orientation polarization, that is alpha subscript O, which is equals to mu square divided by 3 kt. In Clausius-Mosati relation, epsilon R minus 1 dividing by epsilon R plus 2, which is equals to N alpha E dividing by 3 epsilon naught. So now we see the first problem. So the capacity of the capacitor with a dielectric has a 6 microfarad and with an air of the dielectric is 2 microfarad. Calculate dielectric constant. Here the given dielectric constant Ca is equals to 6 microfarad. Capacity of the capacitance with the dielectric is equals to Cd with a dielectric constant of an air is an Ca is the 2 microfarad. Then dielectric constant D is equals to Cd dividing by Ca, which is equals to, this is Cd and this is Ca. So substituting this one, Cd is the dielectric constant within 2 into 10 power minus 6 micrometer dividing by 6 into 10 power minus 6. 10 power minus 6 and 10 power minus 6 gets cancelled. We will get the 1 by 3 is the answer. Here please change into 1 by 3 is the answer. It's certain printing mistake, so 1 by 3 is the answer. Next, dielectric second problem is an dielectric constant of the medium, means epsilon R is 2, and the dielectric field and the field in a dielectric is an electric field 10 power plus 6 volts per meter. Calculate the electric displacement. So D will be find out. The electric displacement vector in dielectric medium D is equal to epsilon naught into epsilon R into E. We knowing about epsilon naught is an 8 into 8.54 into 10 power minus 12 farad per meter into epsilon R is the given 2, and electric field is the intensity is 10 power plus 6. So 10 power minus 12 and 10 power plus 6, we will get the 10 power minus 6. Multiplying this one into 2, we will get 17.7 into 10 power minus 6 coulomb per meter square. Next, in third problem, in a dielectric constant of a medium is n 5, means epsilon r is n 5. Electric field intensity 10 power plus 6 volt per meter. Calculate dielectric polarization. So here dielectric polarization means P is equal to T minus epsilon naught into E. So first find out electric displacement vector D is equals to epsilon naught into epsilon r into E. In the previous problem this formula already using. So epsilon naught value we knowing about that, substituting, and epsilon r is 5 into 10 power plus 6 electric field intensity. So we will get the 44.25 into 10 power minus 6 coulomb per meter square. Now we find out dielectric polarization. P is equal to D minus epsilon naught into E. Here D we find out substituting this equation. Minus epsilon naught is 8.854 into 10 power minus 12 into electric field intensity 10 power plus 6. So we will get the answer 35.4 into 10 power minus 6. So now is in the fourth problem. The electric displacement and the electric polarization. Electric displacement means capital D is the 4 into 10 power minus 5 coulomb per meter square, and dielectric polarization means P is equals to 3.5 into 10 power minus 5 coulomb per meter square. Then respectively we find out the electric field intensity. So we knowing that the formula P is equal to D minus epsilon naught into E, substituting all these values, and E term will be taking left hand side, which is equals to, and another terms will be coming to the right hand side. So 3 into 10 power 3.5 into 10 power minus 5 will be coming to right hand side. You will get minus values. So minus same powers it will be taking common 10 power minus 5. 4 minus 3.5 is the 0.5 into 10 power minus 5. So we will get the answer 0.5 into 10 power minus 5 dividing by 8.854 into 10 power minus 12. Minus 12 taking numerator, plus 12 it becomes, which is equal to 10 power minus plus 7. So answer is E is equal to 0.0564 into 10 power plus 7 Newton per meter square. So finally we will get the, substituting this value, we will getting this value 5.6 into 10 power plus 5, this is plus 5 Newton meter square. The electric line of force traveling from one dielectric is n K1 is equal to 5 to the another dielectric medium is n K2 is equal to 4. Dielectric constant is, this makes an angle theta is n 60 degree. In the boundary condition first dielectric, what is the dielectric constant of the second dielectric? K1 means 5, K2 means 4, and theta 1 is 90 minus 60, we will get the 30 degree. Therefore theta 2 is find out in K1 dividing by K2 is equal to tan theta 1 dividing by tan theta 2 formula we can using. So substituting these values, tan theta 2 we can find out. So in reversible we will get the K2 by K1 into tan theta 1. Therefore tan theta 2 is equal to 4 by 5 into 10 power tan 30. Tan 30 value find out, and substituting this value we will get the tan theta 2 value. If you want theta 2 value, which is equals to tan, find tan inverse of this value. Next, in sixth problem, so find the polarization produced in a dielectric medium of an relative permittivity is 15 in the presence of electric field of 500 volt per meter. Given data, we will knowing about epsilon r is 15, relative permittivity, strength of electric field is 500 volt per meter. Then we find out polarization. Polarization P is equal to epsilon naught into epsilon minus 1 into E. Epsilon naught value 8.854 into 10 power minus 12. Epsilon r is 15 minus 1 and 500. So it is multiplied by this one, we will get in the answer 6.198 into 10 power minus 8 coulomb per meter square. Next is in the seventh problem, the dielectric constant of the sulfur is 3.4. Assuming a cubic lattice, its structure calculate the electronic polarizability of the sulfur. Given sulfur density is 2.07 gram per cubic centimeter and atomic centimeter cube, and Atomic weight is 32.07. Given data, epsilon r is 3.4, density 2.07 gram per cubic centimeter, that is 2.07 into 10 power plus 3 kg per meter cube. We will getting atomic weight is in 32.07. Crystal structure is in sulfur cubic. The electronic polarizability alpha you can determine. So now we knowing about the Clausius-Moshaty relation, that is epsilon r minus 1 dividing by epsilon r plus 2, which is equals to n alpha e dividing by 3 epsilon naught. So alpha e means electronic polarizability we can determine, that's why it's taking it as in left hand side. We will get the formula is rearranged, 3 epsilon naught dividing by n into epsilon r minus 1 dividing by epsilon r plus 2. So here we will knowing about epsilon r value and epsilon naught value. Now we find out the value of n. N is the number of atoms per unit volume. N is equals to Na into 10 power 3 into D dividing by atomic weight. So Na means Avogadro number 6.025 into 10 power 26 into 10 power 3 into D is the 2.07 dividing by atomic weight is given. Atomic weight is 32.07. We find out n value, we will get 3.89 into 10 power plus 28 per meter cube. By substituting this value, we will get the alpha e is 3 into epsilon naught, we will know 8.854 into 10 power minus 12 dividing by n means 3.89 into 10 power 28 we will find out, and epsilon naught is r is in 3.4 minus 1 dividing by 3.4 plus 2. We will get the answer of the alpha is 3.035 into 10 power minus 40 farad meter square. Electronic polarization of the sulfur is in 3.035 into 10 power minus 40 for farad meter square. Next, considering the pure silicon crystal having an epsilon r is in 11.9, and what is the electronic polarizability due to the valence electron per silicon atom. Given n by v is equals to 5 into this one is in, we can write, please it write 10 power 28 plus 28 per meter cube. 10 power plus 28, 10 it can change us into 10 power plus 28. So now we substituting this equation, the alpha is equal to a Clausius-Moshaty relation rearranged, and the above formula it will be same, epsilon a 3 into 8.854 into 10 power minus 12 dividing by n by v will already given 5 into 10 power 8. Epsilon r is 11.9 minus 1 dividing by 11.9 plus 2, we will get the 4.17 into 10 power minus 40 for farad meter square. So please its value changes into 10 power 28. Okay, thank you for watching this video.